So in this problem, a of x is defined as the integral from 0 to x of f of t dt for f of x shown in this picture. So I would prefer to call this f of t. So let's just change that real quick here. We're going to call this y equals f of t, and we'll call this the t-axis. To make it clear that x is not the variable over here, x is the upper limit of integration, so it's like where we're integrating to. Okay, so first we'll want to find a formula for a of x on the interval from 0 to 3. Okay, so that means x could be anywhere between 0 and 3. So let's just put it maybe here. Okay, but at the most it would be is out here at 3, okay? So if x is between 0 and 3, then the shape that you get under the graph of f of t is this rectangle. And understanding that a definite integral is net area, we can find that net area using basic geometry formulas. Okay, so this is for part 1 over there, up here. So the integral from 0 to x then of f of t dt is equal to the net area here of this rectangle. F is positive everywhere here, so I don't have to worry about negative area. So it's just the area of the rectangle. Its height is a constant 3, and its width is just x. So its height is 3 and its width is x, so that's it. That's just 3x. Okay, then if x has to be between 3 and 5, okay, that changes it a little bit. Then this x could be moved out. So the minimum x could be is 3. So our integral, however, still starts at 0. So the integral still includes all the net area from 0 out to wherever x is. So it's going to definitely include that large area, which is 9. And then x is somewhere between 3 and 5. I don't know, maybe right in there. Okay, so the shape of this region is a trapezoid, which you can split into a rectangle and a triangle, or you can use the trapezoid area formula for this. Okay, so the integral from 0 to x, if x is between 3 and 5, let's write it out. What I'm doing visually here, you can see, is I am splitting this into the integral from 0 to 3 of f of t dt plus the integral from 3 to 5 of f of t dt. And I'm doing that because the integral from 0 to 3 is 9. That's that area right there. It's going to be 9 no matter what, because the minimum that x can be here is 3, but our integral still starts at 0. Okay, then for this part, plus the integral from 3 to 5 is the area of that trapezoid. Area of a trapezoid is 1/2 the sum of the uneven lengths, so 3 plus this side, that height. If you look at it, the equation for this blue line here, if you were to think of it as a line on the xy or ty plane, it's just y equals x. It's slope 1, it goes through 3, 3, 4, 4, 5, 5. So the equation of that line is y equals x, which means the height of the trapezoid right at that point, wherever x is equal to x itself. So if x is at 4.2, the way I've drawn it, then y is at roughly 4.2. So those are the sum of the, not 4.2, the height is x. There we go. And that's the sum of the uneven sides, and then times the width. So the width here from 3 to x is x minus 3. Okay, which you can expand and simplify if you want, but that is a of x right there. And then to go from 5 to 7, I think probably from this information you've figured this out. The integral from 3 to 5 is going to be a constant, just like the integral from 1 to 3 is, or 0 to 3 is the constant 9. You would say, well, the minimum that 5 can be is x can be is 5, so we're going to have to include all of this area under the full trapezoid. You can just count squares here for this. It's 1, 2, 3, 4, 5, 6, 7, and then 2 half triangles. That's got an area of 8. Okay, plus an area of this rectangle for that part right there.